Phosphorus 31 is also a spin 1/2 nucleus with 100% natural abundance. However, the relative receptivity is only a fraction of that of proton. The phosphorus 31 signal is split by other spin 1/2 nuclei, especially proton. So the proton-coupled spectrum gives an apparent pentet. It's an apparent pentet because the methylene protons are actually diastereotopic. Phosphorus 31 coupling further complicates the proton NMR spectrum. For the diastereotopic methylenes, the additional coupling with phosphorus 31 adds considerable complexity to the spectrum due to two-bond coupling. For the methyl resonance, we can see more clearly a three-bond coupling constant. I will finish by showing proton and carbon-13 spectra for a relatively simple organic compound that contains fluorine-19 and phosphorus 31. In the proton NMR spectrum, there are 9 protons in 3 different chemical environments. A4 for the methylenes appears as a pentet, but a doublet of quartets is probably a more appropriate description of this multiplet. There is a 3-bond coupling with phosphorus, which is responsible for the doublet, and then there are also 3-bond couplings to the trifluoromethyl group for hydrogen to fluorine. And these couplings happen to be of similar magnitude. For the methyl ester, B3 is far enough away from other spin 1/2 nuclei so that it appears as a singlet. But then the remaining 2 protons, C2, may look like they are 2 singlets, but this is actually the result of a 2-bond coupling with the phosphorus attached to the methylene carbon. In the carbon-13 spectrum, resonance A at about 165 parts per million corresponds to the carbonyl, and it appears as a singlet. Carbon B has 4 lines associated with it, but this is actually the quartet for each trifluoromethyl carbon bonded directly to 3 fluorine-19 atoms. The resonance at about 65 parts per million is also a quartet with a much smaller coupling constant, and that's consistent with the 2-bond coupling of carbon to the 3 fluorines on the adjacent trifluoromethyl. D corresponds both in chemical shift and in multiplicity to the methyl group of the ester. And then carbon E has a relatively large 1-bond coupling to phosphorus 31.